countries now that haven't actually deployed 4G. Some of them call it LTE, and the standard for that 3. Has been completed, executed, and we now have almost 4 billion people connected onto that. So the elements to the deployment of 5G are in allocation and identification of the spectrum, its standards, and commercial deployment. And as you see, okay, the timetable there shows that by the end of this year, all spectrum will have been allocated, and I must draw your attention to the WRC 19 that is going to take place and where a lot of the spectrum issues will be brought. 2019-2020, that is where the standards for 5G will be completed, and we are hoping that the tests that are now being done in 5G will become full deployment by 2020. There are a few issues that I would call attention to that the ITU is looking into as we speak, and these are the transport network support for 5G, network management and orchestration, fixed mobile convergence, environmental requirements, security, quality of service, and quality of experience. You have heard, and there has been a lot of talk, particularly about things like the environmental requirements, where some people are saying that the radiation from 5G is harmful. I would like to tell you that we are continuing to look into that. So far, there is no evidence of that, but the ITU is continuing to look into it. There are also issues of security that have been highlighted, and I think there have been problems between a number of countries developing 5G, but again, the standards that ITU is putting in place are meant to actually curtail the problems that are about security. So, in terms of the transport of 5G access and home, developments have been made to have radio over fiber and to have multi-vendor interoperable 100 gigabit systems, to have good performance in rural areas over fiber, the control of transport systems, and the system that is now being tested, the visible light communication, or what people are calling Li-Fi. There are a number of new standards in addition to what exists, and one of those is the ITU standard on synchronization for 5G, and the other is the new supplement on PON, support 5G front haul. There is front haul, middle haul, and back haul, and the standard that is just being in place is that one that supplements the support for front haul. Now, here's a bragging statement that between 2015 and now, ITU standards have increased the speed of fiber to the home 64-fold. 64-fold. From the time 2015 up to now, the speed has been increased 64 times. Okay. We keep talking about facilitating infrastructure that exists, and G.Fast is a standard that has been put in place to ensure that copper can be used at gigabit speeds.
2 more minutes.
Okay. But I should probably say that from the time in 2017 up to now, the use of copper has been increased 250 times in speed. And as you see, breaking news, G.Fast achieves now 2 gigabits per second, and we are aiming at increasing that to between 5 and 10 gigabits. I was going to speak about hubs, but I see one of my colleagues will be speaking to that. So the only thing that I do need to point out is that there will be additional bands, spectrum bands for hubs. And again, I need to point out to you that it will be up to you to come to Sharm el-Sheikh for WRC in order to determine these changes in spectrum. The radio local area networks are another emerging technology. And again, what I need to point out here is that additional spectrum and regulations for RLANs in 5 gigahertz band will be considered at WRC. Please study and make your vote count. I see my moderator is looking at me. I was going to go to transport systems, but let me say that in marine technology, in aeronautics, in railways that we saw in the past session, it is very important that these emerging technologies be anticipated by you and used when they are around. You may remember MH390, the Malaysian flight that disappeared. It is only after that we worked with ICAO and came to a standard that will allow tracking, that will allow discovery after any eventuality. And the modernization by the International Maritime Organization of the system, the Global Maritime Distress and Safety System, is not complete because they are revamping it. And as they complete the elements of it, they are handed over to ITU for now allocation of the resources that are needed to make it work. Aircraft tracking, autonomous distress tracking, and post-flight localization and recovery, I think, are things that unfortunately started to function after accidents, but nonetheless, we learn and improve, and these are now working well. I already talked about trains. I think the systems that are now in place that have been, ITU has kind of written standards for, will allow trains to be able to communicate between themselves and trackside stations, and this in a lot of ways to avoid accidents and to be able to control the trains in case of accidents. Intelligent transport systems, I think there's a lot that has been said in the news, but the important thing to show again here, the functions between vehicle and vehicle, between vehicle and infrastructure around it, and vehicle and everything. Those standards have been set, and our groups are working on them. But also, spectrum harmonization will be required, and again, that is a function that you need to pay attention to and make decisions about. I do not feel that I can continue with my chairman looking at me like that, but let me say that the way the ITU works, you are our resource. We work through study groups of experts contributed by you member states, by you private sector, to make sure that whatever we do in terms of standards, in terms of licensing satellites, in terms of allocating orbits for them, it is you. So I would encourage you to continue coming to the study groups. That's number one. Number two, I would like to call on you, particularly the ministers here. SADC is not a member of the radio communications sector. The decisions that we are talking about are going to be made at WRC in November, December. My plea to you is to please expedite the approval for the Secretariat to apply to ITU, become members, so that you can organize yourselves and go to WRC with one message, what you want. Otherwise, Africa is going to lose out. Let me also say, in terms of standards, WTSA, which is the other statutory conference of ITU that for standardization, will be in 2020. And again, let me call on you to make sure that you are members of that to be able to cast your vote. I thank you.
Thank you very much, Mr. Ujeje, for the emerging technologies. You ate a few minutes, so the next presentation will be limited to 9 minutes. The next presentation is about a Google Loon project. So I will welcome Dr. Anna Prose to lead your team in the presentation, but the total time for the presentation will be 9 minutes. Thank you.
Thank you very much, Session Chair, and thank you, honorable ministers and distinguished participants. I'll actually have my team come up here with me, mainly because I'm a believer that after 4 minutes I will bore you. So I'm having other people speak to you so that I might revive the whole presentation. Come up here. Come up here. So, there. So we're here from Project Loon. We keep on hearing that we're Google Loon. We used to be Google Loon. More or less a year ago, we spun out from Google, and now we are a alone standing company. We're still under the Alphabet hat, but we are our own alone standing company. The team here that you see is Michael Hancock, and he's one of our business development leads. There's Philip Wambugu, who is our consultant for this part of the world for government relations. And this is Tom, who is our engineer, and I am Anna, and I lead government relations for Loon. The mission of Loon is connect the unconnected. And it's a very complicated, what are you doing? Are you changing? No. We're still here, that slide, let me do it. It's connect the unconnected. And the easiest way to think about it is cell towers in the sky. So we are all used to cell towers on the ground. What we do is cell towers in the sky. It's the next one. The next one. Okay, so I have a video, which is the easiest way if we manage to get it going.
The world are still unconnected. In big towns and cities, providing connectivity with cell towers is economical, as there are lots of people that are willing to connect. But the further away from those towns and cities you go, the fewer people there are, until eventually connectivity just stops. To bring the internet to people in these areas, we need to look up, way up, into the stratosphere. From here, we can provide connectivity across much larger areas, bringing the benefits of the internet to more people. So how do we get there? With balloons. Really big balloons. Beginning their journey from one of our custom-built balloon launchers, our balloons are filled with lighter-than-air gas and released up into the skies. Rising 20 kilometers into the stratosphere, Loon balloons float twice as high as airplanes, well above weather and wildlife. To get to where they need to go, Loon balloons sail the wind by moving up or down into different wind currents traveling in different directions, joining other balloons in small teams over areas where connectivity is needed. Ground stations connected to local internet service providers send signal up to the balloons and then back down to the ground over large distances, allowing people to connect directly to the internet with an LTE mobile phone. When it is eventually time for our balloons to come down, we navigate them to remote areas and work with local air traffic control to manage their slow descent down to Earth, where they're collected by our recovery teams. By repeating this process at scale, we hope to provide continued connectivity to users on the ground, bringing the internet to more people in more places around the world.
So, in a nutshell, how we get to where we need to go is by navigating the winds. And the more we pump air in, the more the balloon gets heavier and it comes down. And we have improved a lot our machine learning throughout the years. This was one of the reasons that we need to fly over countries to collect wind data so that then we can accurately fly these balloons around the world. Now, we've been speaking all morning, of the importance of connectivity and how connectivity changes the lives of people around the world. Loon has had a big impact also with disaster relief. And as you know, when disasters hit, the towers on the ground go down, and the best way is balloons in the sky who are way above the weather. So we fly 20 kilometers above the weather, and we just connect with basic handsets. So on the topic of disaster relief, and since I'm speaking in this forum, we are looking at disaster relief in the region down the road. We're actually, Loon doesn't operate, as you've heard, on our own. We operate with local telco partners. So we are in discussions with local telco partners to deliver possible disaster relief. And one of the countries we are, as of now, discussing is Mozambique. So how does Loon work? We first launch, then we fly, and then we land. I think I can show here a very short story of the evolution so that, you see us here today, we'll tell a story, and probably in 6 months we will have made a lot of progress from now to today. So here's a little bit of a story from the past years. That's the video. No, the video. Okay. So this is in a nutshell a little bit. We started launching by hand, as you've seen, and this is how we launch now. We have 2 launch sites, one in Puerto Rico and the other one in Winnemucca, Nevada, and that's where we launch all of our balloons worldwide. As of now, the balloon's lifespan is more or less 223 days. As you can see, we have made a lot of improvement in station keeping, so we managed to stay over a significant area, especially after we have done the machine learning on the wind patterns. We have over 1 million flight hours with 0 incidents. And, again, this is the part on flying, and then the next session is the landing. We land in areas that are totally inhabited. We work with the local civil aviation authorities to decide where it's best to land. And then we have local partners to go and recover these balloons, collect the equipment, and then either reuse it for CSR, corporate social responsibility programs. There's solar panels on those that we don't need. So we've seen in a lot of countries, there's interesting things that people can do with solar panels and everything and batteries that's on those balloons. And whatever we can't, reuse in the communities, we recycle. So I'll leave the word now to Michael.
2 more minutes. So, Michael, you have 2 more minutes to conclude.
Good afternoon. Sure, we'll go very quickly. I'll just say a few words on the communication systems that we carry on the payload. You've seen in the video that it's the LTE, the service to subscribers, the service to the people on the ground is just a normal LTE signal. For telecommunications people, that's in band 20, band 28 are the ones that we use. It was our choice. We also do backhaul. That's to go back to the national operator. And then finally, if we're over the ocean, for example, to navigate, we connect upwards to Inmarsat and Iridium. I'll turn over to Tom on the other systems.
Just briefly to cover some additional systems, as you can see here, we obviously need power generation and storage systems, so solar panels, batteries, to stay afloat, along with command and control systems that Michael mentioned, and systems for safely descending our balloon in coordination with civil aviation authorities. Then one important subject that is close to all of our hearts is safety, as it is for everyone in aviation. It's really central to everything we do, all of our engineering design decisions, et cetera. But in addition to that, we have obtained a state letter from ICAO stating that we exceed all regulations. And additionally, we have a 24/7 flight operations center monitoring and controlling our balloons and communicating with air traffic control.
Thank you very much, Session Chair. I'll just take just half a minute to just highlight a couple of takeaways that would like the honorable ministers to consider. The first one is because of the many stakeholders in this sector, we have been discussing with SADC a draft sort of non-binding MOU so that it gives us a framework of cooperation and coordination with SADC. It will also enable Loon in coordination with SADC to undertake multi-country sensitization, briefings, effective information sharing, particularly to these critical stakeholders at the lake level and at the country levels. Chair, you will have noted that because this balloon is flying, it requires the signing of the letters of agreement to enable it traverse the airspaces of the SADC member states. I want to report here, Chair, that SADC as a lake has got the highest numbers of countries that have allowed balloons from Loon to overfly their airspace. The flight of the balloons over the airspace will help us study the winds, mark out prohibited and restricted airspaces, security, military, in the countries, and also assess the capacity requirements for the agreed areas of service. The final one, Chair, which is a bit difficult, is sometimes even in one country, stakeholders do not align in terms of consensus going forward. Therefore, in some countries, we have lower, but below them, other stakeholders have not facilitated the forward movement. We are appealing to honorable ministers to urge the member states to help in terms of fast-tracking the realization of this project by having stakeholders come to a quick consensus on the project. Thank you very much. I am appreciative of that chance to talk to you, honorable ministers, through the session chair.
I have a 5-second addition. We have a printout of the payload outside. I don't know if you've already seen the poster. So if you have questions afterwards and on anything that's on there, Tom is there, and then we'll have brochures for you. Thank you.
Thank you very much, Dr. Ann and your team, for the Google Loon project, or the Loon project. Thank you. Our third session will be, or presentation will be about SADC borderless fiber optic network. Mr. Jacob Mudawafa, the Executive Secretary for SATA. Done? Oh, you'll be too? Okay, same time, 9 minutes. Manage them properly.
This one, you point the windows. Okay, make sure you are straight with the windows. Thank you, you're welcome.
Which one there?
So 2 presenters, Andrew Matseke and Jacob. Who is starting, Andrew?
Yes, I'm starting.
Yes, okay, Andrew. Okay. The floor is yours.
Thank you, Program Director. Ladies and gentlemen, I'll get straight to the presentation. We'd just like to share with you a little bit about Broadband Infraco from South Africa, and then also touch on a project that we are running in South Africa called SA Connect. Okay, Broadband Infraco, or BBI as it's called, is a state-owned company in South Africa, which was established in 2007 through an act of parliament. We provide services within South Africa to the SADC region, as well as international connectivity via the WEX cable.
Oops. Which way?
I think I went too far. How does one? Oh, sorry. I just need to. Sorry, I went too fast. Okay, so we are a provider of connectivity to the region. We interconnect with all of South Africa's neighboring countries. The red dots on this presentation are the POPs at the borders where we interconnect with the neighboring countries. Sorry, Jacob. So we are a member of WEX, the West Africa Cable System, and through WEX, we are able to connect, especially the landlocked countries, neighboring countries of South Africa. Okay, we have a project in South Africa called SA Connect, which is a government project to connect facilities, particularly in underdeveloped and underserviced areas. The current phase of the project has got just over 6,000 sites, and in 8 district municipalities that exclude the urban centers of Gauteng and the Western Cape. And as you can see, the categories of sites includes government offices, provide the end-to-end access layer 2 to get from our POPs to all these facilities that need to be connected. So far, since we started the project last year, we have connected 540 sites and out of the 540, 451 have been successfully connected and tested end to end. And we expect to complete the balance within the next 2 months. That's just a geographical view of the areas that we are connecting. The orange, or the coloring that you see, I think it looks like orange from where I'm sitting. That's the areas that we are covering. And as you can see, they are outside of the commercial centers of South Africa. That's just the breakdown per district in South Africa. That adds up to the 313 sites that we implemented in phase 1A and the 400 that we are busy with now. What is very interesting and is perhaps a good case for the rest of the region is the service providers that we are using for the access network. We selected 12 service providers. 8 of them are SMMEs. And it's a very interesting model that has proved to be successful, particularly as in the rural areas, that access network is predominantly wireless. And therefore, the capital investment that is required for rural wireless networks can also be accommodated by SMMEs. Some of the lessons that we've learned, and I'll pick a few of them. One of them being the success of the SMMEs in rolling out these types of networks, particularly as the quantum, the volume of sites that have been released so far has been small due to funding constraints. And the smaller the number of sites, the more it suits SMMEs. And the bigger service providers that we are using are the ones who are complaining that they will perform better when we start allocating them high number of sites in excess of 100 per service provider per district. But for quantums below that, it has actually suited the service providers, the SMME service providers. And then, of course, we have typical issues around security of the equipment and power in rural areas. But we think this model has been more successful than we expected, and we are willing to share the lessons that we've learned with the rest of the region.
2 more minutes.
Yes, thank you, Andrew. So Andrew talked about connectivity within South Africa, and in almost all the member states, we do have typical broadband infrastructure like what Andrew has shown us. In Tanzania, I know there's NICTBB. In Zimbabwe, there's broadband network managed by Tel1 in Zambia and Mozambique. So these are networks within countries. What I'm going to talk quickly is about how do we create this borderless network? How do we cross the borders to create a seamless network? So I've got a few slides, Mr. Chairman. Quickly, allow me maybe 3 minutes maximum. I want to show you a quick video about who are we, what we do. Yes, Chairman, this is live. It was launched in Mauritius by the Honorable Minister of Mauritius last week on Friday. It's a platform, a digital platform, which allows the industry to collaborate. It's similar to WhatsApp, Facebook, or Twitter, but it's more advanced. You go to Google, you go to Apple App Store, you can download the SATA Connect app for any of your phones, your tablets. Please, you're welcome. Everything which is happening now here is live on this platform. So in terms of investment, quickly, Mr. Chairman, a few slides is that fiber is being rolled out across all our member states, across the region. And connectivity, we are looking at high-speed capacity with 5G coming. And all member states have broadband fiber and across the countries, and all member states are connected to submarine cables. And we were in Tanzania 2 weeks ago. The gathering identified that there are few missing links within our region, and an alliance called UCA, United Capacity Alliance, was established to champion the connectivity within Southern Africa and extend it across Africa. And in terms of what we are doing at the moment, Mr. Chairman, is we are busy gathering the data in terms of where is the fiber missing. We call them the meet me fiber points. So these are the points, like, for example, between Tanzania and DRC, we need to close that gap. Between, for example, and I know Mozambique and Tanzania along the bridge, so we need to close those gaps. So this is the map which we are using in terms of identifying the missing gaps across the region. So we hope that by 2020, we should have closed all the cross-border connectivity. This is the map of the submarine cables which interconnects Africa. And Africa is fully interconnected with submarine cables. And lastly, Mr. Chairman, some of the things which we need to consider as we know we are going towards NGN broadband 5G is that investments in high fiber capacity, backbone networks, access networks, and cross-border links, and utilizing existing fiber from our power utility and other utilities, we need to support those investments, and also playing the innovation game, 4IR, starting with simple and low-cost innovation using digital technologies, but with a huge impact, encouraging and supporting new startups, and promote innovation hubs, cities, where innovation will be happening, and also launching digital platforms like what you saw, which we launched in Mauritius, and also looking at the sharing economy. Things like how can we copy things like Airbnb, these new startups for our region. Thank you. This is the end of my short presentation, Mr. Chairman.
Thank you very much. Thank you very much, Mr. Jacob. And that takes us to the end of presentation number 3. The last presentation is from Facebook.